Alright, we do some discussion on the trial exam question, right? For question 1, paper 3, mechanics, further mechanics, a particle is projected with a speed of 60 meter per second from a point horizontal ground. The angle of projectile is b degree above the horizontal. The particle reached to the ground again after 10 seconds. So first question, the main question is find the value of b. Okay, so A, state the vertical component of the velocity in terms of B. So the vertical component, theta is here, right? So, and the speed is 60. So for vertical component, the first mark will be 60 psi B. Vertical component, resolve to here, 60 psi B. Second marks, question is asking you state the vertical displacements after 10 seconds. So after 10 seconds, the particle reach the ground again. So after 10 seconds, y equal to 0. Right? Very simple, right? And third part will be state the value of b. Okay, so the angle of b. So for this situation, you will need to use the vertical movement, vertical constant acceleration equation in order to find the answer. Okay, so you can form an equation y equal to tan 60 psi theta minus half at squared equal to 0. So from this, you were able to find the B angle will be equal to 56.4 degree. 56.4 degree. So for question 1, part 1, A, B, C. Okay, for question 2, find the greatest height reached by the particles. Okay, so greatest height, the total, the part A is state the time of the greatest height. So the total projectile motion is 10 seconds. So the maximum height will be at the first part will be at the 5 seconds, 1 mark. So same things, you can use the equation y equal to 560 psi b minus half 5 square, right, equal to 0. Sorry, no need to put 0 here. You just put this inside the equation. You should able to find the maximum height of y will be equal to 125 meter. Right, just the t you change, right, and you put in the 56.4. Okay, so you should able to find the y is 125 meter. So for question 1, part 2, A and B. Okay, 5 seconds and 125 meter. For question 2, a light elastic string has a natural length of 2 meter, modulus of elastic 1.5 Newton. One end of the string is attached to the fixed point of O of a smooth plane which incline at a 30 degrees to the horizontal. The other end string is attached to the particle of P mass 0.075 kg. P is released from rest at O. 5. Okay. A. The gravitational potential energy could be written in the form of AD. D is the distance from O. State the value of A. Okay, so for first one, the gravitational potential energy means PE. P equal to 0.075 tan d psi 30. Alright, so from here you should able to find the A for this will be 0.375. Okay, for part 1. 2 part 1 A. Okay, B. If elastic and energy that could be written in the form BD squared plus CD plus E, D is the distance from O of P from O, state the value of BCE. So that you need to use the energy in the elastic potential energy, okay, the EPE. So the EPE will be equal to 1.5 times D minus 2 square over 4. So you should able to get an equation that 0.375 D square minus 1.5 D plus 1.5. So as simple like that, your B will be equal to 0.375. Okay, C will be equal to negative 1.5, and E will be equal to 1.5. And when all the energy convert to each other, state the distance of P from O when the P is at the lowest point. Right, so all the energy, the PE convert to elastic PE. So you will put this both equation equal, and you will able to find the D equal to 4, the final answer. Right, the D equal to 4. This is for question 2. Question 2. Okay, not difficult, right? Question 3. Question 3, you have theta here, and you have a P here. Okay, and you have 4 meter here. Part 1. Given that the cos theta equals to 24 over 5, find the radius of turning path. The radius of turning path will be from here to here. Okay, you measure from the particle to the center. So it's the 4 meter plus the small area here. Okay, so for the part 1, state the radius of turning path. So the radius of turning path will be equal to R will be equal to 4 plus 5 times 7 over 25. So the turning path will be equal to 5.4 meter. 5.4 meter. Okay. B. State the value of T tension in the rope. Okay, you can do like that. The tension in the rope, you can see T cos theta. T cos theta equal to 24 over 10. So you get T equal to 250. Tension in the string, in the wire. Okay, so and once you have done this, you can find the sine theta. Okay, the sine theta, you're using binoculars, you will able to find sine theta is equal to 7 over 25. Okay, binoculars. So once you have this, you can use the net force equation. (24 omega square times pi.4 is equal to 2507 over 25. Okay, so you will get your omega will be equal to 0.735. Okay, radian per second. So this is for question 3. Okay, now we go to question 4. A very short discussion on question 4. Question 4. Find the distance of center of mass of the laminar from the side BC. Okay, from the right hand side BC. So your item is like that. Okay, so this is 8, this is 9.5, this is 15.5, so BC is here. Okay, so the question is asking you find the center of mass from BC. How much? Okay, so in order to find this, as you know that you will need to find the center of mass of the triangle first. So for triangle for the right angle triangle, if you want to find the center of mass, will be equal to 9.5 plus 1 over 3 times 6, so 11.5, part 1. Hey, so the area of the triangle, very simple, right? Area of triangle will be 8 times 1 over 2 times 9.5 times 6, so 24. Okay, and next question is ask you to state the horizontal distance of center of mass of rectangular portion from BC. Okay, rectangular portion mean except the triangle. Alright, so mean as simple like that, it will be equal to 9.5 divided by 2. Okay, 9.5 divided by 2 equal to 4.75. Okay, so now you have all the material already. You already know the center of mass from the triangle, center of mass from the rectangular. Okay, so now question is ask you to find the area of the total laminar. So means is equal to, just now 24 total will be plus 8 times 9.5, right? So your total area will be equal to 100. Okay, and state the distance of center of mass on the laminar of side BC. So now you can use the moment equation to find the distance. So you have 8 times 9.5 times 4.75, okay, plus 0.5 times 8 times 6 times 11.5. This one for the triangle is equal to the total. You can simplify 100 x. Right, so at the end you will find the x is equal to 6.37 cm from BC. Right, so this is for the mechanics. Okay, question further mechanics, question 1 to 4. Hope you score well. Okay, tomorrow I will post the paper 6 for you. Okay, a very short discussion about that. Okay, thank you.